Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to continue our discussion of Section 2, Chapter 4, Systems of Equations by Substitution. Now in previous problems we have solved systems with substitution with an equation already solved for x or y. Now we're going to take a look at some problems where we first have to solve the equation for x or y before we can use the substitution process. So let's take a look at some examples to see how this is going to work. So the first example we're going to take a look at comes from problem 2, number 1. It says, what is the solution of the system? 3y plus 4x equals 14 and negative 2x plus y equals negative 3. In order to use substitution to solve a system, I have to have an equation that's already solved for a variable. So I need either x equals or y equals in my problem. If I look at my two equations, neither one has x equals or y equals by itself. So I need to pick an equation and solve for x or y. One of the things you want to do is be strategic. I'm going to go for the equation that already has just y in it. There's no coefficient out front, and I'm going to solve that equation for y. So to solve this equation for y, I've got to move the negative 2x to the other side by adding 2x to both sides. When I add 2x to both sides, I'm going to be left with an equation that says y equals 2x minus 3. I am in the habit of always writing the variable first, so that's why I put 2x first and then minus 3. So once I have the equation solved for a variable, I've got y by itself now. We're going to solve the problems like we were in the first couple examples that we did in the last video. So y equals 2x minus 3. I want to take what y equals, the 2x minus 3, and I want to plug that into the equation I haven't done a single thing with. So that would be this first equation. And I'm going to plug the 2x minus 3 in for the variable y because that's what it equals. So where I see y, I'm going to replace that. The 3 is still there. The plus 4x equals 14 is still there. So I'm going to write a new equation, 3. But where it says y, I'm replacing it with the 2x minus 3 from the second equation. Plus 4x equals 14. So once I've put my two equations together, I've substituted into the other one. I'm going to solve that equation to figure out my value. So 3 times 2x is 6x. 3 times negative 3 is negative 9. Drop down plus 4x equals 14. Combine my like terms, that's 10x minus 9 equals 14. Add 9 to both sides. 9. That's going to be 10x equals 23. And then divide by 10. Now, 10 does not go into 23, and I do not want to make these decimals. I want the practice with the fractions. So I'm going to say x equals 23 over 10, because that fraction will not simplify. Now, once I have my x value, I also have to figure out my y value. So I'm going to figure out my y value by plugging in this x value back into one of the equations. I again like to be strategic about this, so I'm going to plug back into the one I already solved for y. So I'm going to take my equation, y equals 2x minus 3, and I'm going to plug in 23/10 for x. So 2 times 23/10 minus 3. And I'm going to solve this equation to figure out what y is. So Whole number times a fraction, just multiply the whole number with the numerator. 2 times 23 is 46 over 10. And I'm still going to subtract 3 from that. I want to go ahead and simplify 46 over 10. 2 goes into both of them, so this would be 23/5 minus, I've got to make 3 a fraction by putting it over 1 and get common denominators. So between 1 and 5, that would be 5. 1 times 5 is 5. 3 times 5 is 15. So another way to rewrite 3 would be 15 over 5. And if I simplify this fraction, 23 minus 15 is 8. My denominator will stay 5. So I get that y is at 8/5. So once you have both your x and your y value, write your final answer as a point. X was 23/10. Y was 8/5. So this example right here is a perfect reason why we can't rely solely on graphs, because we don't have perfect numbers as our answers every single time. Sometimes they're fractions, and we have to be able to find the exact answer by just dealing with the equations. So if you get fractions, don't worry. You probably still did it right. Fractions are going to happen. So let's take a look at the next example. Our next example, we're going to jump down to number 4 from problem 2. And number 4 says, what is the solution to the system negative 3x minus y equals 7 and x plus 2y equals 6? So again, in order for substitution to work, we have to have an equation that is already solved for x or y. So we need x equals or y equals. In this example, neither equation has x or y already solved for. So I need to solve for x or y in either equation. I like to be strategic about this. So I pick the equation that has already just an x or just a y. For this one, I'm going to go for that second equation that has just an x. Sometimes I don't have that option and I got to do more things than I need to. But for this one, I have the option. So I'm going to solve for x by moving the 2y to the other side. So since it's positive, I'm going to need to subtract 2y on both sides. And that's going to give me an equation of x equals, when I move the 2y to the other side, it's now negative 2y since I was subtracting it. And I still have that plus 6. So I'm just rearranging one of the equations for either x or y. I chose x because I just had to move one thing. Now that I have an equation with x equals, I'm going to take what x equals, in this case negative 2y plus 6, and I'm going to plug that into the other equation we haven't done anything with for the x. So the negative 3 is still there, the minus y equals 7 is still there. What I'm going to do is take that first equation and copy everything except for where I circled. The x gets replaced with the negative 2y plus 6 from the other equation. Minus y equals 7, that's still there. And I'm going to solve this equation now that I've put the two together. So negative 3, distribute that. I'm going to get 6y minus 18 minus y equals 7. Combine my like terms. 6y minus y is 5y minus 18 equals 7. Add 18 to both sides. 5y equals 25. And then divide by 5. So y, 25 divided by 5, is 5. So once I've figured out what y is, I've got the one variable, I need to plug it back into any of these equations to figure out x. I like to go back into the equation I already solved for x. So I'm going to go back to this equation, x equals negative 2y plus 6, and I'm going to plug my y value back in. Y was 5, and I'm going to simplify. Negative 2 times 5 is negative 10, and negative 10 plus 6 is negative 4. So x is negative 4, because this was all about the x value. So if x is negative 4 and y is 5, my final answer as a point would be negative 4, 5. This concludes our lesson on solving systems of equations by substitution without having an equation already solved for x or y. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.